Hey guys, welcome back. We are now starting some of the questions. We are going to practice some of the questions related to bonding and structure, which is related to chemical bonding and atomic structure. And if I am changing the page, you people may see a question. It is from 5070, and the question is telling you that 5070 year 2022. No, it is 2020 and summer 20, yes, and it is QP 22. It means that it is paper 2 and variant number 2 as well. Okay, so right now you can see that there is a question. I have solved this question already. Before moving towards the detail, I would like to inform you that at your level, those students who have not studied organic chemistry till this stage, for their level, whenever there will be any exam like December test or any other test, formula will be given. Okay, so C2H4. But if you are thinking that they will give you the formula of ammonia, please don't think like that. They will not give you a formula like ammonia. They are expecting such type of formulas from you. They are expecting the formula of methane from you. Obviously you should know what is the formula of water, what is the formula of carbon dioxide, etc. These type of formulas they are expecting from you. But definitely if they are giving you the formula of if they are asking you the structure of ethane, then they will give you the formula of ethane. C2H6 is ethane. Ethene is C2H4, which is the question right now which we are going to solve. So such type of compounds, and there is another thing like CH3COOH. This is the formula of ethanoic acid. These type of the compounds they will give you if you have not studied that chapter of organic chemistry with your teacher in your school. Okay, but if you have studied organic chemistry and you are in your mock exams or you are in your midterm exams before your CIs, you are in the final year, then definitely teacher is expecting such type of formulas after teaching you organic chemistry. Okay, so I have clarified this picture very clearly. Okay, now before moving towards this question, I would like to inform you that this question is of 2 marks and they have given you lots of space over there as well. Okay. So I can tell it to you that carbon has atomic number of 6 and mass number of 12. Again, the same story. It can be carbon at 6 at the top or 12 at the bottom as well. So what is the atomic number 6? And now I'm going to write the electronic configuration, which will be 2, 4. And same will for hydrogen, it is 1, 1. So its atomic number is 1 and 1. Again, might be some of you might be thinking then that a periodic table will be available or will not be available. This is the repeated story. I have shared this thing with you people for so many times before as well. Periodic table will be given both in IGCSE and in GCE in case of MCQ and in case of theory, but it will not be given in case of ATP paper. And in ATP paper, all the information related to the periodic table will be given along with the question. Okay. Before moving ahead, I would like to inform you that all those students who are appearing in their exams for December test or etc., they will receive a periodic table with their papers. And if you don't have, you may ask about the periodic table from your teacher. Okay, or if they are not giving you the periodic table, might be they will give you the information related to those elements in the periodic table. Okay, so here it is really important to write down that you are going to write the key for this, and hydrogen is represented with the dot. Okay, so we can say this thing that carbon has how many electrons in its outermost shell? It has 4 electrons, so it is going to share 4 electrons. Look, one carbon has shared both of its electrons with this carbon atom. I can change the color so that you may clarify this thing. This is the red color carbon, and these are the 4 electrons of this carbon. Okay, this is the blue color carbon. The other carbon is blue color carbon, and its electrons are of blue color. Okay, and we can say this thing that dots are the electrons of hydrogen. So we can say this thing that these are the sharing regions. Sharing regions can be this. Okay, this is the other sharing region, and this is the central sharing region between the two carbon atoms, and this is another sharing region, and this is another. So two of the hydrogen atoms are being attached with one of the carbon atom, whereas the remaining two hydrogens are being attached with the other carbon atom. So in this way we can say this is the structure. Okay, is this enough to draw it like that? No, you should write down the bonded diagram as well. Okay, Do I need to draw the overlapping diagrams? Principally, you should draw all these three diagrams, which I have explained you in all of my videos previously, in which I have taught you about covalent bonding. So this is the structure like this. You can see this is the structure, and this is one the other. There is one hydrogen with this, and there is another hydrogen like this. Okay, now you can see this thing. I am drawing the crosses. I am not changing the color here, so you can estimate this thing that these are the crosses and hydrogens and etc. for all of these. Okay, so this is hydrogen, this is hydrogen as well. Okay, so what will be the diagram afterwards? And that is carbon, double covalent bond, carbon. So I have shared this thing already with you, that in case of two pairs of electrons, it will originate a double covalent bond. In case one pair of electron, it will originate a single covalent bond, etc., etc. So this is how we are going to draw the structure of ethene. Okay, so I guess this is the clear picture for this question, and 2 marks are there, so it means that you have to write all this detail. Please don't let the examiner cut 1 mark for any reason. So it is important to write down everything, everything. Your answer should be ahead, your answer should be in detail, your answer should cover all the aspects. Obviously, here they are asking about ethene. We cannot share something related to methane or ethane or etc., etc., but we should give a detailed information related to ethene. Okay, now I'm changing the board towards another past paper question. Yes, it is again summer 20. Yes, and it is QP22, same paper 5070. Okay, here I can share some of the questions of 5070. I mean to say GCE, or I can share 0620, that is IGCSE. As I have shared this thing in my earlier videos, that all the content for chemistry in IGCSE and GCE is perfectly similar now. Okay, so we can say this thing, that what is this, what this question is saying. Some of the parts may be not matching with those students who are just looking into bonding and structure questions. I will not solve those questions right now, so that you people may not get confused. And when I will solve the questions related to the past papers, obviously these answers will be there in detail. Okay, so let's solve this. Sulfur dioxide is a colorless gas, okay, and it can gas which can be found in air, okay. So one should know this thing at this stage. Those students who have done only till bonding, I'm telling for them, and those students who have done like periodic table and acid base and salts, etc., I am telling for them that you should know this thing, that sulfur dioxide has formula SO2. Okay, state one environmental problem caused by the presence of sulfur dioxide. This is the topic. This is the question which is related to the topic of air and atmosphere. Here I'm quite trying to make it thinner and writing here. So A part is basically related to air and atmosphere. This is another topic which I will discuss with you, inshallah. Atmosphere, but this is somehow a general sense as well, so please try to find out such type of thing. So one environmental problem is acid rain. Okay, acid rain is caused by sulfur dioxide. Okay, how acid rain is developed, how acid rain is affecting adversely to our environment, that is a topic which we will discuss when I will teach you the topic of air and atmosphere in detail. Right now, the next is when heated in air, iron pyrite. Okay, when heated in air, iron pyrite reacts with oxygen. All right, okay. Sulfur dioxide and iron oxide, iron 3 oxide, are the products of this reaction. Iron 3, this 3 is telling you, this 3 is telling you that iron has a charge of +3 in this compound. Okay, so construct the equation. This is for those students who have done the chapter of acid, bases, and salts, but for those students, this will not be the question who are done with bonding only, till the bonding only. Obviously, the introduction to the balancing of a chemical equation and introduction to the development of a chemical equation starts from the chapter of periodic table, and it keeps on going. Okay, so please, this is not for those students who are done till bonding only, but I am writing what will be the equation. Okay, so they are saying FeS2 will react with oxygen, and as a result, they are saying Fe2O3 is being produced, and sulfur dioxide are the products. Okay, so if I'm writing here 3 this, so then if I'm writing 2 over there, so it means that 6 is here and 3 and 2. So it means that I have to write like 4, for example, here. As a result of that, might be I have to write 4 here, to make it balance. Okay, so it is 8, and 4 into 2 is 8, and 3 are here. Probably we have to change the number. A bigger number might be, it's like 2, for example, and if I have to write it like 5, for example, it is giving you 10. So it is not completely balanced, but this is the trick to make it a balanced chemical equation. I will upload a balanced chemical equation as well related to this. Now, before moving towards this, I would like to inform you that it is important to write a balanced chemical equation. Okay, so this is how we have to change the numbers, but we cannot change the formula. I am not changing the formula of Fe2O3. I'm not changing the formula of FeS2. I am not changing the formula of sulfur dioxide as well. But it is important to maintain that how to write down the formula for this compound. Okay, so this is really important. Before moving ahead, I would like to inform you that we have to write one use of sulfur dioxide. What is the one use of sulfur dioxide? Bleaching wood pulp. Do we need to know, those students who are done with bonding only, bleaching wood pulp? Those who are done with bonding only, they are not required to do this, but those students who are done with the acid bases and salts, they have done contact process as well, so they should know this thing. Okay, so just give me a sec. um, we have to write the balance equation for basically FeS2, and we have to write it with oxygen. Okay, so with oxygen, what will be the product? We have just written this thing already, and this is Fe2O3 and SO2. Okay, so basically we should know this thing, that how many oxygens are there. It is 3 oxygens in that and 2 oxygens over there, and the balancing of the chemical equation is not that much required, so you can skip that as well, but it is important to write the balanced chemical equation. For example, I am sharing one equation with you, might be you will understand that, but its balancing is quite detailed. You may look into this equation. I will not let anything go on its own, so that you people may not be in the problem. So it will be 4, and it will be 11, and it will be then become 2, and it will become 8. Guys, look at here right now. How many times Fe is there? 4. How many times Fe is there? 4. How many times sulfur is there? 8. How many times sulfur is there? 8. How many times oxygen is there? 22. How many times oxygen is there? 2 into 3 is 6, and 8 into 2 is 16. So 16 and 6 become 22. So it means that these are the reactants which are written before this arrow, and these are the products which are written after arrow. So remember this thing, that the reactants and the products number should be equal. That's why I have taken so much time to make it balanced, and I have told you that it is important to write a balanced chemical equation. Look at here. First of all, 2 marks for this question. If you will not write the balanced chemical equation, examiner will not give you any credit. Okay, so here, liquid sulfur dioxide is stored in cylinders. When cylinder is opened, the liquid quickly changes into gas. Use the kinetic particle theory to describe the changes in the movement and the arrangement of the particles when liquid sulfur dioxide becomes a gas. Okay, so basically it was initially a liquid, and now it is turning into a gas. Okay, it is happening due to pressure change. It is happening due to pressure change when cylinder is opened. So it means that pressure is released. So as a result, the liquid will turn into a gas. So now they are just asking about the movement and the arrangement of the particle. So initially you have to make it clarify. For example, what you will write: in liquid, I am changing the color. In liquid, particles were, particles are, you may say, arranged closer to each other and are moving in straight lines, you may say zigzag movement. Zigzag is also a straight line. Okay, small straight lines. Okay, in gas, particles gain energy, gain kinetic energy, you may say, gain kinetic energy, move randomly, and are very far apart from each other. Okay, so it means that you have to compare this thing. Here I'm writing on the softboard, that's why I can take up, might be taking a little bit the longer space, but when you will write on the paper, obviously you will be able to cover it up properly in the same lines. Okay, so here the tool marks are there, which is just telling you that you should write the movement and the arrangement of the gas particles in comparison to that of the liquid. Okay, so don't write for gas only, make a comparison with the liquid as well. Then sulfur dioxide has a low melting point. Done. So just in terms of structure and bonding, why sulfur dioxide has a low melting point? Whenever examiner is asking that A, B, C, D has a low melting point, you have to explain it according to the structure and bonding. You have to look into the thing either it is covalently bonded or ionically bonded. So you have to know this thing that what are the consequences of any type of a bonding. Okay, so as they are saying low melting point, so what will be the answer here? Sulfur dioxide is a combination of non-metal, hence makes covalent bonding, full stop, due to weaker intermolecular forces of attractions among sulfur dioxide molecules, comma, it shows low melting point. Okay, so this is how you guys have to explain this thing. Guys, let me explain you one more thing. Can you look at this space? Okay, we are using this space. Okay, so for example, this is one molecule of sulfur dioxide. Okay, done. This is one molecule of sulfur dioxide. This is another molecule of sulfur dioxide. Done. This is another molecule of sulfur dioxide. This is a third molecule of sulfur dioxide. Done. Okay, so here I'm pointing it out, I'm spotlighting. So this is the sulfur dioxide. What is the bonding inside sulfur dioxide? It is the covalent bonding which is present inside sulfur dioxide. And what is the bonding inside this molecule? It is the same covalent bonding. But how these are being attached with each other? Okay, please don't move. Okay, so here I'm writing, look at here right now. So these are the weaker forces of attractions which are called as intermolecular forces of attraction. Okay, you may write it as IMF, intermolecular forces of attraction. Okay, this is not that IMF. We are not asking for a fund here. This is the IMF, which is basically intermolecular forces, which is just combining the molecules together. So we can say this thing that in case of sulfur dioxide, there is a covalent bonding in the molecule. But how molecules are keeping with each other, how molecules are just adjusting with each other with through a weaker intermolecular forces. So covalently bonded structures have covalent bonding within themselves, but they are attached with weaker intermolecular forces. That's why they show low melting point and boiling point values. Okay, so this is how it is happening. I'm now changing the page, and it is the second part of this question. Basically, it is the F part of this question. So what is the question? Describe the chemical test for sulfur dioxide. This is for all those students who are done with the lab processes, gas collection, and test for the identification of gases. This I have done in my video as well, so you people might have studied from there. So it is the test and the observation. Guys, you can look into the 2 marks. So you cannot write test and observation in the same line. In the one line, you have to mention what is the test you are going to perform, and in the other line, you must say this thing that this is my observation made from this test. Okay, so what is the test? Pass the gas, pass the gas through acidified KMNO4. full stop. KMNO4 will change the color from purple to colorless. Is that okay right now? So it is a very clear. There can be another test as well, and that is instead of KMNO4, acidified K2 acidified. Acidified, is that important to write acidified? Yes. Acidified K2Cr2O7. And what is the test result from orange to green? Orange to green. But which test is a better test? KMNO4 test is a better test. Here I have mentioned it very clearly. Okay. Now I'm changing the board to another question. Okay, this is a question of year 2021, and it is question number 2, and it is paper 2 variant 1, and it is again 5070. Okay, now here, some of the parts I will not solve because it can create a confusion for all those students who have not studied moles chapter with me. So I am not doing this part right now. This is the E part, which is related to moles. All those students who are done with the chapter of moles in their schools or either with me in my schools, so they must know this thing, that what she is doing here. But here I'm not solving this question in this video. I will make a specific video for moles. Rather, I will make many videos for moles, inshallah. But right now I'm not solving this question. Okay. Helium, neon, argon, krypton, xenon, and radon are Nobel gases in group number 8. Done. Name the Nobel gas that which has the greatest volume composition in air. It is argon. I have taught you when I was teaching you the composition of air. Okay. Here I am writing the composition of air again. What is that composition? 21% oxygen, 78% nitrogen, 0.03% carbon dioxide. Remaining is water molecules, argon gas, neon gas, helium gas. And I have told you that argon is the cheapest among the noble gases. Why? Because its percentage in air is greatest. And number 2 point related to argon, which I have told you, is this, that as argon is an inert gas, as argon is an inert gas, INERT, inert gas, that's why it is used in the bulbs to create an inert environment. Okay, so these are the points which I have already discussed. Okay. State one use of helium balloons. If they are asking about neon advertisement strip lights. Radon is very unreactive. Okay, use the electronic structure of radon to explain why. As this is 1 mark question. Okay, so what is the answer I have already written? As radon is part of group 8, comma, have stabilized electronic configuration, that's why it is unreactive. Okay, you may write it very clearly. If you are not mentioning group 8, you can because it will be okay, even because it has been mentioned at the top. Okay, but you can say this thing due to stabilized electronic configuration. Please don't write like that it has a complete electronic configuration. No, stabilized electronic configuration, that's why it is not going to make bond, that's why it is an unreactive gas. Okay, so two isotopes. This is an important question for those students who are appearing for isotopes paper. Okay, two isotopes of radon are shown. One of them is Rn86 and 220, and the other is Rn86 222. Okay, so both of them have same atomic numbers, 86 86, which is different. Their neutron is different. What was the definition of isotope? These are the particles of the same. These are the atoms of the same element. Particles is not also a good word. These are the atoms of the same element having same atomic number but different mass number due to the difference in the number of neutrons. Okay, so two isotopes of radon are here. Give one similarity in the atomic structure of these two isotopes, same number of protons. Okay, give one difference in the atomic structure of these two isotope protons, these two isotopes. Okay, and that will be atomic mass is different due to number of neutrons. You should write it that same number of protons, that is What is that? Is 86. And atomic mass is different due to number of neutrons. And then you can say this thing that in Rn20 it is 220 minus 86, whereas in that it is 222 minus 86. This is how we can calculate the number of neutrons. Okay, now I'm going to take you to the next page, and this is a question of a question extension of the same okay question. Okay, now I will also not solve this question because it is also a chapter of moles. Okay. Before moving ahead, I would like to explain you a sample of neon has a volume of 21 decimeter cube at room temperature and pressure. The temperature of the sample is increased. The pressure remains constant. Describe and explain using kinetic particle theory what happens to the volume of the sample. Guys, I have taught you that there are two types of the laws related to the gases. One of them is Charles' law and the other is Boyle's law. Guys, we have discussed this thing as well, that these are the laws which we will explain you in detail when we will teach you states of matter chapter in AS chemistry. But right now we are just taking a benefit from these laws. These are not the complicated laws which you people are unable to understand. Quite simple laws. It is just that temperature is directly proportional to volume. Higher will be the temperature, higher will be the volume. Lower will be the temperature, lower will be the volume. Whereas in case of Boyle's law, pressure and volume are inversely proportional to each other. So one can say this thing that describe and explain using kinetic particle theory that what happens to the volume of the sample. By increasing the temperature, particles will gain kinetic energy. Particles will move away from each other, hence volume will be increased. As I have written it a little bit the words are a little bit far away from each other, far apart from each other. You may use these lines more constructively on the hard copy. The pressure of the sample is increased, and at this time, what is constant? Temperature is constant. Okay, so you may write this thing that pressure is inversely proportional to volume. So by what we will see, by increasing the pressure, particles will come closer together, hence volume will decrease. Particles will become closer to each other. As we will increase the pressure, particles will become closer to each other. That's why they will occupy a smaller space, hence pressure will be decreased. Okay, so please don't forget this thing, that these questions are not of a very huge number of marks, but you can get one mark only if you will write down very much appropriately. So please don't lose marks on such type of very easy questions. Okay, so here then there is again a question. It is related to silver is a transitional block element. Guys, this is a question of 5070 year 2021 May June, and paper number 2 variant number 1. Okay, so silver is a transitional block element, and its proton number is 47. Use the periodic table to state the number of occupied electronic shells in an atom of silver. Guys, this have been discussed among us already. That group number is telling you that how many number of electrons will be there in the outermost shell, whereas period number will tell you how many electronic shells will be there. Okay, so they are asking about the electronic shells. For this reason, I am keeping the periodic table here. Okay, guys, you can see this thing that this is the period number 1. Only these two are in the period number 1. Okay, this is the period number 1. Then this is period number 2. This is period number 3. Okay, this is period number 4, and this is period number 5. Okay, so it will have how many electronic shells? 5 electronic shells will be there. Okay, this is the silver written over there as well, and if you will keep the symbols in your mind, things will become easier for you. Okay, now 5 electronic shells, as silver is in period number 5, so it is important to write down the reason as well. It is important to give the comprehensive, compact, condensed, clear type of an answer. Okay, your answer should occupy clear information. Describe with the aid of a diagram, the metallic bonding in silver. Okay, examiner has not mentioned the labeled diagram, but you should draw a labeled diagram. Positively charged nuclei should be like this, and negatively charged electronic C should be like this. Here are 4 lines in which you should give a proper description. What will be the description of a metal? In a metal, comma, positively charged nuclei are immersed in a negatively charged electronic C, full stop, positively charged nuclei are making regular layer-like structure. Or you may say about negatively charged electrons, you may say valence shell electrons C. Or this C of electrons is developed by valence shell electrons. Only the outer shell electrons are making this C. Inner shell electrons have no role. These electrons are not part of any positively charged nuclei anymore. These positively charged nuclei are losing these electrons from their outermost shell, and they all are moving here and there. So when there is a metal and electric current is passed through that, electric current is basically flow of electrons. So in that case, positively charged nuclei remain same, whereas previously present or the old electrons are replaced by new electrons. Okay, so this is what happened in case of a current. Okay, now they are saying give two physical properties of silver that are only characteristic of transitional block element. Okay, so what we can say is that for those students who are done with the topic of atomic structure, even then they might have some information related to periodic table. This is a general information. This is not a very particular information which should be taught to you in the chapter of periodic table. This you should know in hand, or if you don't know, don't worry about that. I have taught it, by the way, in my videos. If you don't know, you will get it. Your teacher will tell it to you in the chapter of periodic table. Okay, so it's not a big issue at all. Okay, so you here we can say this thing that transitional elements not for all the metals. Okay, but not all the metals. So what we can say, high melting point, high melting point, high density, acting as a catalyst, comma, it's another acting as a catalyst. Okay, there are some other properties as well, but catalyst property is also somehow considered as a part of the chemical property because it is a participant of a chemical reaction. But these two properties, high melting point and high density, are purely those two properties which are specifically associated with the with the transition block elements. For example, some of the elements have a density like 9.37, whereas sodium has a density of like 0.98. Okay, so it is just telling you 0.98 or 0.97 is the density for sodium. Sodium is an element of group number 1, whereas 9.37 is the density of one of the element present in the transitional block. So it is just telling you that it's a huge difference when we are saying that melting point is high. So we can give you the example for that. Sodium has a melting point which is very lesser melting point, and it is around below 100. It is below 100. Okay, so we can say this thing. And in case of iron, it has a melting point of 1550. Okay, so we can discuss the things in a comparison as well. Here I'm going to share the melting point values of melting point values of what melting point values of the elements of group number 1. Okay, so melting point of iron, I have shared it with you, but for sodium, I would like to inform you very clearly that what's the melting point of sodium. Yes, it is the same which I have just shared with you, 98, 98, and its density, I would like to explain you that how density of transitional block elements is greater than that of sodium. It is 0.97. Again, the both of the points are very clear and correct. The density of sodium is 0.97, whereas melting point is 98. But in case of iron, I have just told you it is 1550. So it is just clarifying that melting points of the transition block elements is far greater than the melting points of the elements of group number 1. Same goes for density. Okay, so silver nitrate is a white crystalline soluble salt. Name a suitable combination of an acid and insoluble base which can be used to prepare silver nitrate. Okay, so this can be part for those students who are done with the chapter of acid, bases, and salts. Here I can tell you that name, we have to write down the name. So formula only will not be the correct thing. I should write this thing very clearly. It is not for those students who are appearing for the exam of bonding in December test. Okay, so please be very clear about that. Okay, nitric acid, and what will be the base? It can be silver oxide. It can be silver oxide, and it will be prepared by excessive reagent method. I will upload the video of excessive reagent method inshallah shortly as well. Excessive reagent method. So this can be explanation for that, but I'm explaining it again and again that this is not for those students who are doing that chapter of bonding till their exam. Okay, so this is this, and now I am on year winter 2021, and question number 7 is here, and it is again 5070. Okay, so state two physical differences in the physical properties of sodium and diamond. Okay, sodium can conduct electricity. Sodium can conduct electricity due to availability of the mobile electrons. You have to write the complete details for sodium, and there are no mobile electrons in diamond. This point should be written as number one. Whereas what about number two? Sodium has a very low melting point of 98 degrees Celsius, whereas diamond has a melting point which is greater than 4000 degrees Celsius even. Okay, so such type of the physical properties must be written. This is the symbol for one ion of sodium. Here number of protons remain same, 11. This plus or minus thingy is just changing the number of electrons. So number of neutrons, 23 minus 11 is equal to 12. Now then number of electrons, 10, as this has lost an electron. That's why there is a plus sign over there. Okay, so these are the questions related to the balancing of a chemical equation, can be asked from all those students who are done with the chapter of periodic table. And this is again the topic which you people, those who are done till bonding or dull till periodic table or acid, bases, and salts, have not done, because this is a chapter which is called as reversible chemical reaction. This I will teach you over there, inshallah. And now I'm taking you to the next page. Okay, so there is another question. The question is about the elements in group number 5. Guys, this is also 5070 and group number 5 of the periodic table. Here you can see this thing that density of antimony is missing, whereas melting point of arsenic is missing. So they are saying you that use the information in the table, predict the density of antimony. We have to predict it. So our density should be within the range of 5.73 and 9.8. Okay, so we can select any number. For example, 7.2 can be a right answer, 7.3 can be a right answer, it can be even 8.0 can be a right answer, but it should not be 9, not at the edges, not at the last points matching with the next figure. Okay, so whenever they are asking you to predict, it means they are asking for a for not for a very specific number. You can select any number within that range. Okay, so for example, if you are writing 8, okay, then it will be considered correct. But remember this thing that you have to write on the unit. Units are there at the top. If you will miss the units, you will get 0 out of 1. Please very clear about this. Gram per centimeter cube. Okay, and then they are saying suggest why it is difficult to predict the melting point of arsenic. Okay, you can see this thing that here the value is decreasing, and then the value is increasing, and then value is decreasing again. So increase, decrease, increase, decrease, not a specific trend. So we will say trend is irregular. Trend of melting point is irregular, not a regular trend. Okay, so you have to mention this thing in very clear words. Then there are two compounds of phosphorus, R and S. You can see this thing that this is R in which there are charges. So we can say it is an ionic compound. Okay. It is sodium phosphide. It has formula Na3P. How we have seen? Because we have seen this. Okay. And then it is a compound of phosphorus and hydrogen. It is PH3. It is just telling us that R is an ionic compound because it is a metal and non-metal compound. This I have written already. And this is the covalent structure for PH3. And PH3 is called as phosphine gas. Okay, so explain in terms of structure and bonding why R has a high melting point and S has a low melting point. Okay, so the same thing, if you will write that R is an ionic compound, it is formed between positively charged and negatively charged ions. And then you should say this thing that there is a strong electrostatic forces of attractions among the particles, electrostatic forces of attractions among positively charged and negatively charged ions. That's why they are holding each other tightly, hence high melting point is associated with Na3P, sodium phosphide. If you're talking about compound S, we can say this thing that phosphine is what is a covalent structure, and due to in weaker intermolecular forces of attraction, phosphine shows a low melting point. Okay, so weaker intermolecular molecular and electrostatic force of attractions. And you have to write this thing that that there are molecules for phosphine. Okay, covalent structures are making covalent bonding is originating molecules. Okay, and you have to say positively charged and negatively charged ions introduction in case of compound R, then you people will get 4 out of 4 marks. Okay, last part for today's video, and that is related to explain why compound R conducts electricity when molten due to mobile ions. Okay, full stop. You may write down the full stop, or you should write up good information. Heat breaks up the electrostatic static attractions, and what happened, and ions become what, become free. Okay, hence they can conduct electricity. Then they are saying draw a dot and cross diagram for the molecule of S. Okay, you can see this thing S. Okay, so it is P, and this is here, and this is here, one H, and this is the other H here, and this is the third H here. Okay, so this is this, you can say this is this, and hydrogen over there, it is like this, you can draw it like this. You have to mention that this is P and this is H for electrons, and you should say this thing very clearly that P has this and this. This is 15, so 285. And what about the hydrogen? It is 1 and 1. Okay, so this is how we have to write the electronic structure. Then they are saying calculate the percentage or biomass of phosphorus in this compound. At this stage, those students who have not studied moles, this will be a little bit more for them. So it is taught to you when I will teach you the chapter of moles, inshallah. Thank you very much, guys. So I'm going to upload it shortly, and inshallah, you will learn lots of information from this video. May you all rise and shine in chemistry. Take care of yourself.